So the next presentation, we also have two presenters. It's from Abbott, and we have Seek. And they are going to talk about how they are using Pi system and also a Seek product, that's one of the exhibitors, to do data analysis of data. And they are going to talk about two applications. One is the CIP, or clean in place, and the other one is the filling application. So thank you very much, Seamus and James, for being here. Julio. So
I'm not James.
No.
Sure.
Julio.
Perfect. So unfortunately, James had a family commitment and wasn't able to make it over. So Julio is going to be doing some of the introduction for the actual Abbott side of the presentation, and I'm going to be taking over some of the engineering side that actually James was working on. All right. So with that, here we go. So agenda, we're just going to go through a quick overview of both Abbott and Seek, and then go on to the two use cases we mentioned, some analysis we were able to do to improve asset utilization in the clean in place phase, and then also some continuous calculations of overfilling giveaway, and then some just overview on the different products we were used to actually get to our engineering analysis. So with that, I'm going to turn over to Julio to give a little overview of Abbott.
Hello. As you can see, I'm not James Lee. I'm Julio Lopez from Granada, Spain, and I support in the part of the presentation of Abbott Nutrition. Abbott is a pharmaceutical company with a long history, more than 125 years. It was founded in Illinois at the beginning of the last century, in Illinois, Ohio. Right now is a pharmaceutical company that today is looking for new ways to bring better health to people. No? This is the slogan. This is the more important part of the company nowadays. This company is one of the Abbott Nutrition. Abbott, as companies, is looking to be in the top of the world companies regarding the nutrition. Right now, I'm happy to say that Abbott is the number one in adult nutrition, and also is the number one just in USA in pediatric. We are looking for increase this position around in the short term, but this is the number now. No? Abbott has different divisions, and we are covering from the infant to the adult age. So we have nutrition, we have diagnostic medical devices, and branded generic pharmaceuticals part of the company. So in my specific situation, because I'm coming from a plant, we are in the nutrition. Also, James is in the Abbott Nutrition part of the company. In terms of sales, the nutrition part is the most part of the company. We are about 33% of the sales, and also because of that, this part of the company is the most important. Nowadays, the efficiency around the productive center are looking for performance and for tools like Seek that can support us in this journey. If we have a look into our nutrition, we have three different functions. This is the pediatric. It's related with the infant formula, growing up toddlers, and supplemental mothers. If we go to the adult and medical, we have the supplemental nutrition for the adult people. Just keep healthy the people. That is one of the main rules. and if we are going to support some disease like diabetes or cancer or kidney. Other important function that we have in our nutrition in the performance, we are supporting the sport and fitness enthusiasts and also active and healthy. If you were here on Sunday, I remember one marathon that was sponsored by Abbott. It's one of the new part of the company. So here some brand that maybe you are familiar with them. The first one is Similac. Here, if you are children, you have the option to buy this kind of product. Ensure is for adult, and EAS that is for athlete or sportive people. I'm very proud to say that we have a lot of innovation and reference around all different parts of the news and the best companies. Well, at the end, we are a big company. This kind of reference is very good for us. I'm talking about the relationship between Abbott and Osisoft. Is the kick-off relationship was in the 1999 when we started to install the first Abbott server in Ohio. It was a single installation, very basic in the architecture, in the plant site. Also, the project were coming from the plant were never being a good global structure. No? After enterprise agreement that was signed in 2007, we started with a better structure. We took advantage of the resources from Osisoft, and we established a common strategy. We started with three sites, and also we introduced the figure of a new role in Abbott of coordination, a central coordination of Osisoft. At the end, right now we have 10 sites in the enterprise agreement. We would like to introduce the 4 sites that are remaining right now. Last year we started with a very big asset framework and event frame structure around the plant. And also SIG was introduced in the portfolio of system that we have in Abbott. No? I'm going to hand over the presentation to Samos. Right. He's going to bring you information about SIG.
Yeah, so I'm going to be presenting a bunch of work that James was able to do himself. But just a quick overview of what in the world SIG is. So we're an analytics application that uses data that's stored inside of Pi. We connect through all the Pi servers and AF servers that Abbott has using the AF SDK, and provide just a real quick way for engineers to do ad hoc analysis, create context by doing a number of different searches and pattern searches, and then share the insights either through publishing back to CoreSite, as well as actually just sharing the workbooks and displays users are able to create inside of SIG. So Abbott's overall goal, again, is to improve total plant productivity. They have 14 sites all over the globe. And in order to leverage the existing assets they have to create just more saleable products. So what does this come down to? For the 2 use cases we're going to talk about is reducing time and non-productive states. So that's like these cleaning phases. And then reducing non-saleable product through reducing overfilling. So the first use case, Abbott's got a ton of data. So since 2008, they've been collecting data at a number of these sites. And James wanted to contextualize all that data so that he could determine how long his assets are in his various states. So In particular, we're going to take a look at the clean-in-place phase. So here's a general kind of cartoon of what this clean-in-place system looks like. It essentially cleans the different streams between product runs. And while the unit's in clean-in-place, it is not producing any product, obviously. A couple of unique things are that all of the variables we're going to be looking at are actually measured right here in the clean-in-place system, but they're actually physically observing the changes that are taking place in a number of different circuits. So there's some difficulty without contextualization of picking out exactly what you have a single time series and picking out exactly what that's measuring at any given time. So here's a kind of look at what the data looks like when you view it in CoreSite as well as in Workbench. And what we have is, again, some different step count numbers. And the main first step is, again, contextualizing it. So we had to take, there's a tag in here that lets you know what circuit is currently running. And so James was able to do a search in Seek Workbench and pick out all the times when a particular circuit was running, like circuit number 2. And then those are identified up here in those little blue bars we call capsules. So just moving on here. So now that we have a little bit of a structure, we're able to move on to some more in-depth analytics. And what the first thing James wanted to do is identify the different sub-processes inside of a clean-in-place. So there's, as mentioned, as it was up on the slide earlier, there's a different phase where you run acid through, then you rinse after the acid, you run caustic through, you rinse after the caustic, and then you do a final rinse as well. And so James had a hunch that they may be actually rinsing too long after the acid and the caustic phases. And he wanted to test that by taking a look at the data and seeing if the conductivity sensor up here was actually going past spec after the process was running through. So in order to build up these searches, you can see there's a number of little kind of grayed out bars up here. These each represent a different search. So at the top is the search for the individual circuit runs. That's like circuit number 2. Search for that. And then at the bottom of that was the different phases. So we identified, when the pump is on, and we're in a particular step number, and we're below our conductivity set point. And he's able to combine all these different logical searches to identify the particular time periods of interest. And these time periods were times where he thought he was over-rinsing. And so the final product are these little orange bars up here. And they're able to, and he's at the bottom here, you see is a summary, which identifies basically all the time that's available that could be saved if a set point was changed. So the idea here, again, is that it's a very interactive model, and he can change any of those different searches, and the aggregate product, these times where he's over-cleaning, get reflected in that. So I'll just mention this is, you'll see this is one particular clean-in-place phase. This is about like 4 hours or so. At the bottom here, you'll see like this little mini-map, and you see these little tiny orange dots. Those are all of the different clean-in-place operations over the last 5 months. And so another view that James wanted to look at was actually sequentially just looking at all these little dots, all these little tiny clean-in-place operations, and taking out all the time in between. So there might be multi-days in between these clean-in-place runs, but he wanted to just have a view that very quickly allowed him to compare all these sequential clean-in-place runs. So a lot of different views and a lot of different tools to make sure that he's able to look at these models and see, yep, these little orange periods of over-cleaning, they look pretty consistent. That looks like an opportunity he could have to make an improvement. So the challenge here is we have a ton of data. We needed to basically assess the asset performance, and the asset state as well as the measurements overlap one another because we have a bunch of different circuits being measured by one particular time series. So it's very difficult to produce solutions that scale out without additional context being added onto those data. So we take a look at all the data stored in Pi using Seek Workbench, and James was able to interactively build up a model which tells a story, kind of captures the time periods of interest, and presents it in a format that allows people to see here are potential times where we could make a set point change and also quantify the results of those changes. So just some real quick calculations is he was able to estimate that he could reduce his CIP cycle time by about 20 minutes, and that leads to about 3 hours of increased production per circuit per month. So it's a pretty big piece of time that's sitting on the table that they can go now and try to address. All right, so our second use case here, a lot of people in food and beverage industry do some type of filling and packaging, and what James and Abbott were doing is looking to reduce their scrap and overfill, but also make sure that they are always maintaining the actual label weight on an individual box. So this is what a lot of the data looks like coming out of Pi using the Pi data link. And this is how James started. And so James, they started, there's a ton of data here. So they get about 20 filler heads, each running at about 240 cans per minute. And so there's a lot of data points being stored at a really fast pace. And so, again, Abbott uses data link to retrieve these data sets and also an SPC tool for some further analysis. So one of the interesting things James wanted to take a look at was actually taking those, contextualizing the data and turning those spreadsheet calculations into continuously calculated new time series. And so what we see up here is those tiny orange bars at the top. Again, all this data analysis starts with contextualization. So he was able to search for all the times when his filling mode was in fill, as opposed to maintenance or down or cleaning. And so now we can only look at the data when we're actually filling. And then he was able to run his set point versus the actual measured weight. And then with his new continuous kind of loss calculation, he wanted to aggregate that over some different time periods that were of interest to him. So you see the second set of 3 bars here. These represent his shifts. So this is the first, second, and third shift up there. And what he really wanted to know was, hey, how much are we losing per shift? So he was able to aggregate that continuous calculation. And now he knows he's got basically how many grams of overfilling per shift is being lost. So this is potentially going to be used for motivation in terms of reporting out, maybe a little contest or something like that. And then the second line here is just a different type of aggregation, and this was more maintenance focused. So this is actually the standard deviation of the overfill. So he wanted to know basically how variable is that overfill. And when this standard deviation of this overfill starts to rise, that's when they know that they need to perform maintenance on the machine so they can bring that set point back down into what they're looking at. All right. So the challenge here, again, is we've got a ton of data coming in at a very fast rate, and we wanted to basically ensure that not only quantify how much was being given away, but also make sure that we're not ever falling below the package weight. And so the solution, again, we use the Pi system to get that high-speed data, get it collected, and the Seek Workbench is able to, again, contextualize some of that data, pull out those different various states, and then continue on to aggregate those calculations over whatever the engineers see fit. So James is able to, again, set that filler weight closer to the set point, and then make sure that everyone is aware of the current performance. So you can kind of see before and after a maintenance period, they were able to really reduce that spread in their overfill. So this was the before, that's the after, and then they were able to actually reduce that set point. And so he wants to make sure that when they start to see the filling get to situations that look closer to that bigger spread using that standard deviation calc, that they're able to schedule a maintenance period so that they can get back down to their ideal performance. So what were some of the key things, especially key OSI soft products that were part of this? They had the enterprise agreement, so they're able to get all the data. They're able to add new data sensors, such as that conductivity sensor, and add it in, as well as making sure that all the set point measurements were added and recorded. The data link was key to some of the initial analysis. And then Seek actually takes advantage of some of the things from the EA licenses, like the unlimited server access and that kind of stuff. And then also, Julio's going to talk, I think, in his next presentation a little bit about some of the other work that Abbott is doing with the Pi integrator. So. And then finally, views that were created there in Workbench that James wanted to present to a wider audience. Seek supports, again, publishing some of that stuff back to CoreSite. Here we go. So just a little bit about the Seek product that helped James very rapidly get these analyses up and running. So again, we're an engineer-focused application that allowed James to connect to all the data in all of his different Pi systems, contextualize it, and our goal at Seek is to be able to enable engineers to really rapidly perform these calculations and run these analysis. So all the slides you kind of saw up there and all those worksheets, those are things James was able to really whip up in like an afternoon or a day of work. So we want to take these really kind of complex, potentially daunting challenges, and through allowing users to build up a bunch of small elements like individual searches and combining them together to kind of take these big daunting problems and make them a little easier and more straightforward to deal with. So again, kind of the challenge is to provide data-driven insight into their process. It's difficult to accurately identify slower process states but that are adversely affecting production and create models and validate them over multiple data lines and data plants without some particularly interesting contextualization. And so the solution was, using that 10 years of data that they have stored in the Pi system alongside some analytics packages like Seek. They're able to provide contextualization, allow engineers to kind of rapidly explore and iterate and share those models. And the results are really improved process engineer productivity. We like to think we helped James show off a little bit to his bosses and reduce the amount of time that his engineers are working in spreadsheets. And then kind of continuously quantify those results, such as the overfilling, as new calculated signals running forward. So this is James's contact information. He knows a lot more about the nuts and bolts of the individual process. And then that's me. Feel free to contact either one of us with questions. That's clearly before I started growing the beard. I probably need to update that photo. So with that, any questions?
Thank you very much. So do we have any questions for James, Aka, Julio, and Seamus?
My name is Łukasz Mielewski, Twinings. I'd like to ask, what's the value of having Seek if you have got Pi? What's the difference, and maybe what are the limitations of Pi system you overcome by Seek?
I think that I don't want to speak for James, but we like to think it's more of like an iterative tool that allows kind of more exploration without really kind of rapidly being able to contextualize and change things and kind of help with that iterative process. And then once they got to some views that they really liked, then those are the kind of the more permanent things. So they can write that back to Pi. So there's some exploration type work that I think that Seek can help out their engineers with.
I'm going to talk about
examples.
I'm going to talk about from the point of view of a plant. I recently received the Seek tool at the plant level because we have a corporate or a division infrastructure of Seek, and each plant has the Pi system connected or indexed. I'm playing about 2 days or 3 days with the tool, and the tool is a very good tool at the end. We are going to play more, and the process engineers are very engaged with this kind of new tools. Also, we have at the plant level all the PyCoreSign, all the tools from Pi, but however, this tool is doing you an additional application that nowadays Pi doesn't have. You know?
It's like you replaced process book by Seek?
Well, it's something like a Google, you know, where you can search a capsule of same things, you know?
Yeah, so I was just going to say that again, I'm just trying to kind of help with that exploratory phases. So really, a lot of the problems we're seeing engineers with is they have huge multi-year data sets, and how do you cut that multi-year data set down to the 10 or 15 times of an occurrence that's going on that you can actually gain some insight out of, right? So especially with that CIP, you got these huge data sets. Only one circuit is cleaning every 4 hours. So over like 5 months, you have maybe 20 hours of data you're actually interested in, right? So we want to allow James to search for, I'm interested in this circuit, and when it's in this phase, and really condense those huge data sets down to really small, usable things that he can look at and make a decision about, and gain some insight about what's going on.
So you mean that you couldn't achieve that with Pi itself?
Sure. Again, it's just another tool set that they like to use. So.
What you saying? Could you say again?
I meant that. So it means that it couldn't be achieved by Pi applications. To looking for the events from past for the specific events you're.
Yeah. So you can set up. You don't have to. You can search and then going back without having to have created that event per se. We kind of search for those machine states. And kind of live display them to the user. So if you say, hey, I want to look for when a temperature is above 90 or 92, or like between 92 and 95, we can just go show that to you instantly, and then you can modify it without having to kind of set any structures up.
Definitely, it's a quick wins if you are looking for root cause analysis tool. You know?
Okay, thanks very much.
You can stop by the booth. I can maybe explain a little better.
Hello, Tom Hassink from the Netherlands. You said that when the variation increases, they have to do maintenance.
Yep.
How did you inform maintenance?
How do what? Sorry.
Inform the maintenance department. How did you implement it in the business, that part?
Yeah, so that, kind of like when to go from this before to after. They haven't, I don't want to speak for James. I think that's something they're looking at doing now in terms of setting up an alert, but they at least wanted to have that continuously calculated value, and that gets them pretty close to that next step of that's definitely something we're looking at automating and making sure that maybe spins out a work order or something like that. That's the next step. So.
Hi, Steve Hewitt from Rockwell. I noticed you had an interface to the CMMS. Is that which direction does the data go, and what likely uses would you put that connection to?
So we have connections in where you can read out kind of those transactional events, those start and end dates, and then they actually show up as instead of like a user can either calculate these capsules right here that define these start and end dates, or they can actually be pulled out from a system like a CMMS system that would say, hey, something occurred between this time range, and it just shows up as an element that an engineer can use in his analysis. So,
okay. And I was thinking CMMS would tend to be a point in time rather than a period of time.
Yeah, so the points can show up as well. They come in as events. So if that's something that you want to create potentially a period of time from the event to anything else, like it just gives you a reference point that you can use inside a Seek.
And can you trigger towards the CMMS as the...
We have a full API that you could write whatever you want, and those are things we're looking at doing.
Okay, thank you.
Okay, thank you very much. Thank you again